Excuse me, I should have got some water. I would have preferred the water. Crash.
Hello, how are you?
Good.
You need one clicker?
Yes.
Okay, this is next, and this is previous.
Okay. Bill, you're here for I2RS? Okay. This is going to be a more friendly discussion. You might want to just come up. It's discussion time, so you might want to come up where you can talk if you really want to.
Actually, we might want to just.
Yes.
Maybe after this break.
Sure.
I come very shortly. I want to talk to you about something.
That's fine. I'd be glad to.
Yeah, just inform me.
That's fine. I have I2RS after this one, so if you miss me.
There's a break.
Yes, I'll be glad to talk to you.
I'll catch you here.
Yes.
Okay.
Thank you. Okay, there must be someone left their mouse, they're going to be unhappy sometime, or is this the normal? I didn't think,
That's for Mac.
that's a Mac, so I mean, I can unscrew it, it's just, I'll just put it here, I'm sure someone will come back for it. And there's another one, boy, we really rock. Okay. Who knows? Okay, frustration. Wow. It crashed. Oh, it's worse. It's worse. Did you know what happened on the way here? One of my hard drives flipped, so I'm just sort of babying. So we'll get started. I do not know what to say.
Exercise my head is exactly what I'm saying. We can't have one just like here on the table.
Yep. Well, we're just gonna, with this particular graph, we're going to go through the basics. Because they weren't, I don't think we had any of those people other than Joel in the previous meeting.
Unfortunately, it is. Very interesting.
Yes, so I'm going to go 15 minutes with what we've done. And then say if you want to talk about bits and bytes, come to their small circles. And Joel will come and talk, and Gene will come, and Mark will come, and maybe Bill will come because he's done stuff. And that's pretty good. I had hoped I had set it up for the national people. I'm at a high level of frustration. I've done everything. I've gotten what to do. Yeah, it's just like.
You work for sure.
Answers how to use protocol. Really sucky.
pleasant discussion.
I'm not having a little discussion with Abe. Leah's gonna get Abe if you don't come see me. I'm like, okay. What? Oh, I don't mind if she excuses herself in session because it has to be one-on-one with Ken. Okay. That gets better. Let's see if I can get it. Okay, I've got that to talk about. How do I say this again? Do we need it selectable? Do we need it selectable by the transport?
We have yogi scores, XML, Jason, that kind of press conference or very calls. Transport is just like the tweet choose. So you can export XML or JSON inside of the press conference.
Transport with,
That just says it.
okay, but we're not looking at TCP versus UDP versus.
This is just the formatting stuff. Basically, that was recently.
Okay, and
Yes. Oh, there you go.
Good afternoon. Welcome to the second I2RS session. So as I just pinged Joe on Jabber, since he's the only person there, the purpose of this specific session is to actually do deep dive and actual work on protocol related stuff. And this is sort of a partial follow-up to our discussion on our first session and also our discussion with the NetConf group that we just got out of. What we'll be doing is we'll be having a small amount of recap of where we are, some discussion about some of our pain points, which largely are driven by terminology issues more than the semantic issues. And then once we've gone through that relatively short end of things, what we're actually going to do is we're going to invite everybody to please come up to the front of the room. We're going to start doodling on paper to actually talk out this out loud. So this does mean that there will be a point where we sort of go off Jabber and we'll be able to support anybody remotely. But that does not seem to be a problem at the moment. Have you started the blue sheets? If not, I'll start them.
how much do we have for roll pass? Okay, I'll start the summary. I'll just start the summary. We'll try to do it without continuing. Hi. Since I see that some of you weren't here on Tuesday, I'm going to go through a quick summary for those of you who were Please be patient with us. How many people were in the meeting on Tuesday? Okay, so I am not crazy. By Thursday, I wonder if I still have brain cells left. Please, Eric, Lola, I'm thrilled to have you here. Stop me and ask questions. This is really, this is the way it works. Okay, I'm going to briefly,
It's not working?
wish it would help if it was, something was plugged in. Yep. Comes out. Meet Metco. Where's the dongle?
Right there.
Ah, there it is. Got it. That should work then. Not yet. Strong. Ah, there it is. Just took a moment.
F5.
So thank you for coming. There's blue sheets going around. This is going to be a session, as Jeff said, that we're going to go through the summary, and then we're going to pull up chairs and have a different type of session. We're going to draw pictures up here, ask questions, and talk through issues. So don't feel embarrassed if you want to see the summary and don't want to go the deep dive. We're happy with you being here just to get a background. Well, not going to work. You're going to have to get the something. Okay. Our whole goal in this next session is Jeff and I are trying to push version 1 out. We're trying to get a set of requirements for this protocol to the ISG by May 5th, the protocol to the ISG and NetConf, and then do hackathons. Because we've specified everything we can, and I think we're tripping over. You're going to have to run it. You're tripping over things. We've got an approved RFC for the problem statement and the architecture, and we've got a whole bunch of requirements to the ISG. Hit it again. And we're working on the last set of requirements. And those are ephemeral state and data flow and protocol strawman. They all have to do with how the data flow works, what sort of extra requirements we have. Do we need XML? Do we need JSON? Do we need to worry about how much it overloads? And then validation. So this is what the data flow is. The protocol strawman is trying to give you the examples in RESTconf and NetConf. Go ahead, Jeff. The RIB, the filter, the topology models are all working fine. Go ahead. And we're going to try interims just to push this over, and we'd appreciate your help for review. We're just trying to, in this phase, to get the requirements, hand it off to NetConf, and see if we can start the NetConf back and forth. Go ahead. Okay.
Actually, once you need the clicker.
Okay, I2RS, this is my hackathon picture, and keep going. One more
Clicker
down.
works.
Okay, now it works.
Yeah, push down.
Oh, wrong way. That's cool. Okay. So we originally started a hackathon, and we thought we would participate. Eric went kindly and did the lead subscription to the Gang Push, and then we tried to just get an environment, because the hackathon in '94 we had much problem trying to get an ODL environment up. This time I preloaded the ODL environment, and it took me about 20 minutes. Download it, that was a long time, and then run it, it was much better. I, of course, ran the ODL environment on a Ubuntu. Well, Edwin Cordello had done that and set it up for us, and he couldn't be here, so he sent it. Our problem is he was probably running on a fairly large server with multi-cores, So it just kept coring on our laptops, going back and forth. So being hackers, we decided we're going to try a new goal. Maybe it was a better goal. And our goal was to set up an environment with Ubuntu native and a VirtualBox, try to get MinNet and MinXNet set up routers, use the Yuma Pro, which is a downloadable free netconf CLI to netconf, use Quagga as a router so we can add and delete routes, and use Cisco TelF as our netconf server that would act like the I2RS agent and try to add a model. And myself, Don Fedek, Jason Stern, Lucy, and Mamadou. And Mamadou, if you're here, I'm so sorry if I've mispronounced it again. Tau. And it's really cool because he's a first-time participant from French Guiana. So I was real thrilled about that. So it actually worked. We got further. This is what we did in about 6 hours. We got the builds working. We figured out the CLI. We downloaded the conf-d. We got it up and going. MinNet took a little bit more to put in the virtual environment. It was without the virtual environment. In the regular environment, the stuff came up, and I was in the middle of hacking this RPC. Now, the way that I thought to do it in the hackathon was simply to make it as another protocol like OSPF. And when it wrote over the configuration, it wrote over it, which means it sits at a higher priority. Seems really simple. Okay, keep in mind this was a really simple. So it just had a set of glue, and it looked like another routing daemon, and it wrote routes into the route table. Should be that simple, hopefully with lots of routes. Okay, that gives you all the details. You can read it online. Now, the reason the push subscription is the pub sub was required from I2RS. And so Eric is gotten code in ODL, and ODL's data model that they use for topology is the I2RS data model. So you basically, if you're using that, you're using an I2RS data model already. And that data model's basic concepts are what Tees is using for traffic engineering, and they're doing Tees. So this is a fairly simple piece. Okay, so they had a netconf API, they pushed it through a subscriber to netconf to the publisher, where they published interface states, ACL, and routes. Sound familiar? And they also had a subscriber that was just a terminal. And that was, they were working on the delete code, delete subscription, and they've already demonstrated the create. Okay, so they've been working along. And the reason we finally got, you'll find out later on why we've said we've just started implementing it, because it makes a whole lot more sense if you start playing with the code. And there's bits and bytes in this one tonight. Go ahead. We don't have our router up and glued, so we'll post the source code when we get it done. And we hope to show this and another demo at IETF 96. We hope to show both the filter-based rib and the route rib, and the subscription shows you the topology. Those are all the I2RS ribs. The rest are things like BGP ribs, and we'll hope maybe we'll show a BGP rib too. Okay, this is where we had a long discussion on Tuesday. And what's the background for this? One of the fun things the chair gets to do before they send things off, let me take one step back. I2RS is a reuse protocol, as I said earlier. We're reusing netconf and we're using RESTconf as our chosen protocols. And we're telling the netconf working group, which is handling netconf and RESTconf, what changes they should make. This is a new style the ISG is encouraged. So as you see, it's already borne fruit. There's the push model coming at netconf for lots of things. but I2RS is coming in with ephemeral state and some of this push and traceability. So what we have to do is look at it and say, before we send them version 1, what's left that we have to work on data requirements? So the chair gets the joyful thing of finding someone or doing it themselves to actually look at the data flow requirements. And I took a crack at it myself, but please, if you are better at this, don't feel shy. So the first thing we have, and we need really some implementation. Notice how we're beginning to turn from this is wonderful theory to what works. One of the things that we started this process a year ago, maybe more, 18 months ago. We went out and said to people who were doing ODL, who were doing other open source, who wanted this I2RS interface. So what do you want? How do you want to dump routes? And I talked to one person working on open source, and they said, I already, on my I2RS client, check everything. I just want you to check the bytes. And if it fails, and I pick up the pieces. I think if we were in another protocol, say AKA BGP, we call this the ability to shoot your foot. And if you shoot your foot, you shoot your foot, but maybe it's the type of advanced technique you might need. But I need, I'm trying to contact the original suggester to see if he still wants it after another 18 months of development. But I ask you, if you're working on development, let me know if you want the minimum checks. Just check that the bytes came off the wire, because you're doing your checks in the I2RS. So that's one. Then someone said, well, maybe I want a little bit more. I really want referential checks. I don't want the musts. I don't want the leaf refs, because that'll take more time. Okay. That's another option. The standing option is the full netconf option. Given no real strong thing for version 1, we will do the netconf full validation, which may take time. If we get 6 months and we get a lot of implementation feedback, we'll send back a comment saying we need to have the minimum referential. Now I'm going to pause here. Are there any implementers in the house? This sounds like a doctor, but yes. Are there any implementers in the house? And would you like to weigh in on your comments in your code? Okay. You can also send a note to the chairs privately. We really, to discuss your issue, discuss how you might want it. But again, given nothing else, we will go with full validation until we find something else. Okay, now the second one. We've agreed that although some people are using protobufs and IPFix in some of their prototype code, they really didn't provide us enough information or input to start using protobufs and IPFix in the first version. We'd be glad to go on to it. We'd be glad to change to it. But at this point, that's all we have is a standard netconf, restconf, XML, JSON formats, which are defined. I'll pause here. Any other implementers in the house who want to say something? Okay, same option. Jeff and I would just love to hear something from people who are actually coding, or you don't have to code yourself. If you can go talk to your buddies who are coding this sort of thing, do tell us, because otherwise we go with the default in version 1. Go ahead, Jason.
Sorry, Jason Stern here. I know this one's come up a few times. I understood you guys are converging on making a couple of mandatory implement.
This is mandatory to implement.
But also in the preliminary spec, you're going to try to have a hook that would allow other proprietary extensions or whatever that may start off as proprietary and may get standard later, but
That's
it'd
true.
be good to make sure you separate so that people could use other transports or whatever encodings.
The experience we're seeing at a couple of the vendors that do have this stuff in flight is that not everybody's starting with netconf, not everybody's starting with any particular external transport such as gRPC or Thrift. And basically what we're likely to see is a rendezvous towards common data models, which is something we're seeing IETF wide, some level of common transports, and at some point we're all going to have to do something to interoperate. Right now all IETF has is a common set of things that are IETF specifications are netconf and yang. At some point we may decide, what does the mapping of one of these things look like into one of the other either transports like gRPC or formats such as protobufs.
There is no reason after we ship the first protocol requirements over to netconf that we can't take a new set of requirements and finalize. As Jeff and I have found, it takes longer time than we thought. So if we close on this and next week you say, or in a couple weeks and you say, oops, I missed it, just start in with proposing something. Okay, now the next one is we need to have resource constraints, okay? So the I2RS actions will overload the router or the switch. Now, this may be plugged into some of the OEM that helps you track it, but this is a piece where we're going to say we can't overload the router with I2RS, and we've got to have some ability to bring it back. And that's sort of where we got on Tuesday. Other people have asked, right now we have a single pane of glass for config and a single pane of glass that's been on the list. And you have to think of that just like what I had in the demo. The config writes a value. There's a priority between the two panes. There are two panes, config and I2RS. Both panes have a value. Let's say for the moment, I2RS is 10 and config is 1. Then I2RS would win. And if you wrote a route with config, I2RS would write over it. And I will go through some examples. I'm just trying to be clear for this one. Okay, we're not going to do OEM to OEM protocols or IPFix, and that's it for our summary of that. Okay, this is an overview of the protocol. Okay, it is meant to be simple, but where we are running in is this used to be the world of config before the ops state changes to netmod. So some of what we're struggling over is terms that really don't sort of match what we're doing in the demos. That's how we went to the demos. You may laugh, but this is probably something you've seen before. So this is the previous world. This is the RFC that says you have metadata about config, state, data, notification, and operation in your Yang model. You have an I2RS client and server that exchanges an intended config that it wants to apply to the server, and it gets derived state when something like BGP or LDP generates things.
So Sue, if I could stop you here. Who here in the room has seen some form of this op state type stuff in other presentations, including netmod and netconf? Now this is important because a lot of the places we're hung up on has to do, number one, with consistent terminology used in netconf, and number two, the impact of how ephemeral fits in with the op state terminology that has been introduced for OpenConfig. If you don't understand this, you're going to be lost. So if you have questions, please come to the microphone.
Please ask now, because I assure you, the reason we're going over this is if you try to read it and then you see it change because we've tried to adapt to the changes that are happening due to the op state draft from netmod, we just want you to be informed. It is a frustration to the authors and to other places, but it is where we are in the IETF. Now, this is the RFC 6244, and ephemeral state dropped into that. So it goes from intended config to one that's applied to derived state, which hopefully to the naive looks as easy as I thought it was. Okay, so if we look at it,
Sorry, Sue, just
Yeah.
as Jason here, just back on the previous slide. I know we're having some discussions about this, but I just wanted to note, in the bottom left, you're showing intended as separate from ephemeral. And I think we'll may want to make sure we're consistent with the other slides on
no,
running.
I'm sorry. That was, the box was supposed to be all intended.
Okay.
My apologies. Just a minute. I'll do oh. I don't see the pointer. Oh, is that the pointer? Pardon? It didn't come out, so, oh, okay, no pointer. Oh, look, was that you or me?
That's Jack.
Ah, thank you. Okay, just a minute, we'll put it back in slide mode. So over here, I've got a great, I hope, can you hear me in the back without the mic?
Yeah.
Okay. The ephemeral state is all of this here as the applied config is transmitted from the intended config and the ephemeral config to the applied. And then when you get to derived state, it's like BGP. Oh, that's right. I should have done that. BGP and OSPF or MPLS do that. And that was fun. Okay. Let's go on. So the way if you see it in the documentation, we turn that into intended config, applied config, and derived state. And the real thing is, if you go into your Yang models and see config true, it occurs in intended state, the ephemeral config, and the applied config. But the applied config is read-only. Config false is all the derived state. Okay, memorize this little document if you read documents, or just put it next to you, because this took us a little bit to dig out of the op state stuff. Now, for a very simple temperature, let's assume we're in an energy efficient world. And we're sitting in one of these rooms like I was upstairs, and the default is to let it go to 80. And I'm getting sleepier and sleepier. And I think we should do something and turn it back to 72. So again, you have the desired temperature, degrees Celsius, the actual temperature for operational state, a very simple one. So again, you have your desired temperature that goes from a running to an intended config and then gets applied, and then you have an actual state. So what happens if you have this online, please reset my temperature, I'm having a hard time falling asleep in I2RS. Well, the I2RS client would overwrite, overlay, excuse me, thank you. The term is overlay the 80 degrees. On top of the 80 degrees would lay the ephemeral 72 degrees. And because for our example, it has higher priority for me to be cool, it will turn to 72 and that will get applied. And then hopefully sometime the derived state, which is the temperature you're reading, will get down to 72 and I will be comfortable and not fall asleep.
Actually, Sue, if you could go back.
Yep.
Show of hands, who in the room is following this example?
Sorry. Hi, Bill Fenner. I have a question which I've had since I saw this slide before. So since we're now talking about let's everybody understand it. The thing that I don't quite get is what's ephemeral state? You only have one state, right? What is ephemeral state?
So,
Because I think there's only one temperature in the room, the current temperature, if
But-
you're reading the temperature.
But if you're reading the temperature, that's the derived state.
Right, so
If you're
back a
config-
couple of slides, it showed that there was a separate thing that was ephemeral state. Another, there you go.
That's the intended config. This is this box here,
Up in the top,
up here.
second one down on the right-hand
Ah.
side, ephemeral state. What's ephemeral state?
Would you mind?
Yeah.
So let's walk through these things real quick. So let's go back to the slide that we just left. So one of the things that's really causing us problems is a lot of these names are coming from things that are stock netconf materials. You look at things like candidate, and that probably makes sense. I apologize to the people online. I'm not going to stand to the camera. So candidate is specifically the store on a netconf server when you're allowed to actually edit the configuration on a temporary scratch copy that is not in effect. So candidate has a name that everybody thinks they know what they mean. It has an explicit meaning in the netconf data store protocol. The same thing is true for startup. You think you know what that is. It is specifically the data store that is present on some systems, because not every system needs support a startup data store. Running config is one of the things that confuses the hell out of most people, because you look at this and you say, this is obviously what the box is running. No, in the netconf sense of things, it is the data store that reflects a config that has actually been committed. They also have a form of the data store that is writable running. So if you've used the old iOS routers, maybe you changed something on the command line, it took effect immediately. That was a writable running type of criteria. So those are, despite the fact that they have very simple, very English normative names, don't mean exactly what you think they are. They're specifically data stores within a netconf context. Now we start getting into things that are not in the existing netconf documentations. Some of these things are verbiage that have been introduced as part of the open config efforts to document operational state. Operational state in netconf today just is simply a config false node. Allows you to read the current state of what is actually in effect. This could be some amount of information from what has been configured, but it is also in many cases some piece of information from the running state of the router. For example, this BGP peer is up. This static route has this next hop. Intended config is basically the state that happens once you've applied a running config and you say go. The thing is, there could be some level of latency from the point that you apply a commit for a running config to the point where the running config has an impact on the state of a box. And this can vary for a lot of different reasons. If it's local box, it probably commits almost instantly. Very large scale box, you do something and maybe it takes it a while before it actually goes into effect. Maybe 10 seconds, maybe 10 minutes. Or if you're in a massive distributed system, like we're looking at for some of the remote mount stuff in netconf, this may be something you change to a local data store, and it may take half an hour before it's applied to the network. We get into the ephemeral candidate stuff. This is where we start introducing I2RS concepts. So what do we mean as I2RS by ephemeral? Number one, we do use it in the sense that English does. This is something that does not generally persist. It doesn't, it hangs around and can change. We intended to say it does not persist. If you were to reboot the box and we were to work from the 3 standard netconf data stores above, the I2RS ephemeral state would not be present without being reprogrammed. And more importantly, the thing that we're actually implying is that on top of the running config, or as the intended config is the op state guys are trying to have us call this stuff now, we now have ephemeral state as a layer. So you have running, you have on top of that, some of your priority is set up that way, some amount of state that is being overlaid or overridden. And that state, if you happen to clear the I2RS piece of it, would flush out and you would still have the original statically configured stuff. Question?
So I was scratching my head earlier, and I think I know the answer now, but the candidate on the upper left has nothing to do with the candidate in the green box?
Exactly. So a candidate, the item listed as ephemeral candidate is basically, I have written some ephemeral configuration and waiting for it to take effect.
So could you fully explain what the candidate on the top left is?
Candidate top left, so I'm going to draw an analogy to iOS XR or Juniper boxes. When you do edit config, make a change, and to the point where before you type commit, you can actually show what you've changed. You can actually do things. You can see what you're, basically what is the scratch pad before you write it out. That's the candidate.
Igor Buskin. Jeff, can you elaborate a little bit on the difference between intended config and applied config? In particular, is it just a timing issue, or maybe the server basically decided to apply, say, most of the intended configuration, but not all of them? So it will be like a permanent difference between intended and applied.
I will make my best attempt. This is one of the points where the OpenConfig guys have been iterating with the netconf group trying to get this stuff nailed down. It's tricky. They have obviously one thing in mind, and IETF is taking time to sort of fully converge on it. To the best of my understanding, it is exactly that latency. So I do my, again, sticking to a Juniper router as an example, since that's what I know. I edit my config, that would normally show up in the candidate config. I type commit, it moves to the running data store. That running data store is now effectively the intended configuration that will take some amount of time to percolate through the system to become applied. And I'm about to be corrected, I think.
All right, Jason Stern, just one subtlety there. I don't think it's always timing based. So for example, if an interface exists on a line card and a line card is not physically plugged in, but you have pre-configuration for it, it can sit there forever. So it's not just a timing thing.
Thank you. That was actually the detail that I was missing. So in some cases, you may say, prepare for something that could actually exist at a later point in time. And then we'll get to the applied config, when such things happen. For example, you plug in that line card, it comes up, it knows what to do because of that configuration that was intended for the thing. And then sort of at the bottom of the stack is once we've actually done all this stuff, we actually have the derived state. Now, what is the operational things going on?
One more point for clarification. Intended config and the ephemeral config are shown as one sort of bigger box. And is it always the case that they come down together, or can you have intended config come down and then the ephemeral override it? I thought it was the latter.
That was actually one of the discussions that we were having just before we left the room from NetConf. And I know Kent Watson was suggesting to us that perhaps a better way to draw that picture is that the intended config of the device is probably closer to the running config, which is coming from what we tended to call static configuration in I2RS sense, with the ephemeral config applied to that as well, either as an overlay or override mechanism. So the intended probably is the union of these two.
If I could do a good graphic, I could show them overlay.
Gotcha.
You can do the graphic, but from a protocol point of view, the arrow that goes down from there, if the intended config has already been pushed down, then the other thing just comes down as increment.
Right. So this actually goes into something that I don't recall being in the slides. We actually have some Yang. We have some Yang later on, but the meat of your question comes down to actually what does the netconf protocol operations or the netrestconf protocol operations do to refer to these individual components? And so we have examples of the kinds of things that you would actually do in terms of edit operations, that sort of thing. But let's go back to the diagram for a second, since I think it actually gives us things. So let's ignore for a second the deep details of what netconf or restconf are going to give us. Actually, before I go down there, Bill, did you have a question?
Well, maybe I should let you go down there. I still don't understand what ephemeral state is. Like I understood everything you said, but there's still just one state. Like it's not that the normal temperature is 72 in the room and the ephemeral temperature is something else. The room is 72. The desired temperature is different between the intended config and the ephemeral config. But the state, there's only one state. The state is what is happening right now.
The derived state is only what's happening right now.
Okay, so if you go back like 3 slides, there's something about state and ephemeral state, and that's what I'm not getting.
Right here?
No, to the operations, it's in the blue box in the upper right corner in an early slide.
And that's where, we probably should be calling at least one component of this, ephemeral configuration.
Okay.
That's called right.
Yes, ephemeral configuration, ephemeral state.
So when you write the yang.
Yeah.
When you write the yang, you actually write the yang just the way you write the regular configuration, except you use the word ephemeral. So you have,
And that's ephemeral config.
that's ephemeral config, but in your config area, you can have notifications, right? When you write your yang, there's a notification, or you can have an RPC operation, or you can have operational state.
Actually, I think I see where your question is coming from. So part of the problem here is that if we go back to the actual yang for the thermometer model.
Yep.
So the thing that is somewhat confusing here is we provided an example, with a desired state. This is, piece of configuration, and we have, a piece of information that allows us to say what this thing actually is right now. That's what we see on the screen in front of us. And I think the next slide has the ephemeral config.
Do you want me to go down?
Yeah, one slide, please.
Do you want
We're looking for
we're
looking for config ephemeral, which is in your example. There we go. So this is what happens when we actually apply the ability to do ephemeral type of stuff. And we'll come back to the full check, conversation in a second. This is an example of a data model that allows for a static configuration to be overlaid with a temporary value that does not persist. So if you think about it, and this is why the thermostat model sort of makes sense for a lot of people. When you're programming your thermostat at home, you're going to set it to 20C. You're going to be, set as level of comfort. And then, somebody's going to say, I'm too hot, too cold. They're going to wonder, or poke a couple buttons. It's going to take effect for a period of time. And if the thermostat resets, it goes back to 20C. That state of putting in the temporary value that is on top of, the static configuration is the ephemeral configuration state.
Right. What's the ephemeral state?
The ephemeral operational state?
Yes.
Okay, so this is where we start, this example is not the best example of that, and that's probably why you're confused. So this is an example in a configuration schema where we want to override static things. This is actually, several IETFs back, we did these nice Venn diagrams about how static configuration and ephemeral configuration could be either fully disjoint, they never touch each other, or we may allow for some amount of ephemeral configuration to override, the static configuration. So in this case, we have, ephemeral configuration state where the node that is the operational state happens to be shared. Obviously, it's the same thing that we're looking at. We want to know what the effective temperature actually is. Other modules, especially the ones that are fully disjoint, may have, for example, a complete subtree, for like ephemeral static routes that do not share the same schema as the system static routes. If that is a fully disjoint model, in that case, the operational state is ephemeral. It may not be there. There may be no nodes there whatsoever, even if the container is expected to be generally present. It's fully ephemeral. Basically, it's being tagged as this is something that only belongs when it's a fully ephemeral module.
Another example might be if you had an ephemeral edition of simply one BGP feature. Maybe your roller was a ephemeral feature. And then when you turned off the ephemeral, you would not have the state related to the ROAs, if you know BGP ROAs.
Sure. Sure. I guess I get this, the operational state in relationship to a ephemeral config that is disjoint from any other config. I'm not sure I see the point of labeling it separately, but maybe I will.
That may, Bill, I may take it out for future things because it seems to have caused more configuration and more confusion than aided. Those are just logical diagrams.
Yeah, and I think the thing that's confusing is that, ephemeral state, is just, it's standard, config false as far as, the system and the consumers are concerned. The big difference is, in terms of labeling the stuff and making it present in the Yang model. The model is when the entire model is ephemeral true. There's no static configuration state. It's not guaranteed to be present on the system. That's really the subtle difference.
Questions, please. This is the time we want to walk through this.
Tarek from Cisco. A quick question, probably a typo. The applied config here is under config false, but on another side, it was showing under config true.
That is a typo.
Okay.
We actually had slides on Monday where that had been the case, and we've been steadily moving these.
This is the correct one, and I was supposed to stop at this one.
Actually, if this is the correct one, then I have a question. So the applied config can be overwritten?
No.
Okay, so that's read only then? Oh, that's confusing then.
It is confusing. That's why I was about to get into the protocol level details. So let's take any questions that are not relevant to that, and then we can actually hopefully clarify this.
That confusion comes from the joyous off-state debate. Okay.
So related, actually a little bit. Say if I have intended configuration which are missing a parameter, okay, but it's filled with template. Okay, so for example, it's the template value, default value is 10, okay, and it was missing. So this 10, is it going to intended config or applied config?
So in the case of default values, especially in the context of ephemeral configuration that does not overlap static configuration, it's really no different. The difference really being that default, much like in static configuration, only gets instantiated when a related node gets done. So like, for example, a leaf node that has got a default value may only instantiate when the container that contains it, or the leaf list that contains it, becomes instantiated itself. So if you instantiate a ephemeral piece of configuration, the related default they also instantiate.
So I don't think that you answered my question. So is it intended or config or applied or both? Okay, so if let's say I just miss because I don't know, it's a local policy issue what to put.
I think in the concept of what the open config guys are looking for, it is part of the intended config, and it may actually show up as a explicit node it's definitely going to show up as part of the operational state. There may not be a node present in the configuration tree, but it's effectively there. So it's a portion of the configuration that's tied to the ephemeral stuff.
Right. So it's basically it's equivalent to intended, right? And the other question is that let's say I was asking for 10, but because of like a local policy limitation, I can do up to 9. Is it possible that the server will do 9 and it will be applied configuration and they will be different, or it should reject the configuration response?
So you're getting the validation, and we're not there yet.
Yeah. Okay.
Good question.
Good question.
Please don't forget that one.
Okay, so show of hands again. How many of you are now understanding this general model? Hopefully more hands. We're doing better.
We're doing better. How many of the people who don't understand it?
How do we know if we understand it or not? That is why I didn't raise my hand.
The people that are sure they don't understand it.
Okay, so given what these things mean, there are impacts on the netconf protocol and the restconf protocol. Let's stick mostly with netconf because that's the slightly more complicated version. Again, the stuff that's across the top are things that are netconf data stores. And the netconf protocol was very much set up to serve the netconf data stores. You do an edit config by default. If you don't specify the data store, you're editing candidate. If you are doing a get, by default, you're getting operational state that happens to include running. The ephemeral stuff does not exist. And even if we set I2RS aside, the whole point that the open config guys have for their operational state stuff, and there's this sort of disjoint behavior between what's intended versus what's applied, that's not something that's in the core netconf protocol. So this is something that netconf is having to deal with completely aside from I2RS. I2RS is really adding just an extra layer of subtlety there, and maybe helping to suggest part of the solution space. So edit config, when you go to actually change something, once a target data store, what you're doing, you can specify, in a system that's writable running, you can edit config directly on running, or you can do candidate. It also allows for other data stores. So I can actually say edit config target equals ephemeral, for example. And whether this is allowed or not will be determined, whether or not we actually have, actually go back to the Anglese, whether or not we have ephemeral true. So basically what one would expect is that if you do an edit config and a ephemeral true node is not present as part of the relevant configuration tree, no, it shouldn't take effect. It's probably a validation error of some sort. Okay, could you go back to the other slide? Yep. Nope, one more. So same thing is true of get. Get has two purposes inside of netconf. It gives you, when you're creating a subtree, what the configuration that actually is running is. It's actually the applied configuration, sorry, the intended configuration from the context of the open config guides. Mostly running, but it's effectively, what the system actually has, in terms of its applied configuration.
Are you talking about box now, or are you talking about this box? Going down to this blue box?
So that's actually, yeah, it is down to the blue box. This is what the this is the running state of the configuration. Just stick to the netconf only for a second. With us without I2RS. When you do a get, you're going to get, for example, if you're talking BGP, here's this BGP configuration. Here's the things that have actually been configured and have been committed, and they're part of running. You will also get config false nodes. This is outright operational state. It doesn't exist in something that you can edit. The thing that changes when you apply I2RS, to this general picture, is you are now able to do a get that will include any ephemerally instituted state, which might be the config. So if you're doing, in the thermostat example, a overlay of the intended temperature, so you're setting it down to 18C because you're a little bit chilly. You're a little bit too warm and you want to cool it down a little bit more. That's a temporary value. You would expect that to show up in your get because you've actually done that as, what is my intended temperature right now? It is no longer what the static configuration says is 20. I should be able to get the 18 there. Does that piece make sense? I'm seeing some heads nodding. That's good. Same thing. Oops, please go.
Sorry, so just Jason Stern, just a clarification question. So you're saying if you do a get on the node in the data model of desired temp, a get will return the 72 degrees, but a get config would return the 80 from that same node?
Yeah, we're getting there. So if you do a get config, and which I hadn't actually gone to, if you do a get, you should get the configured ephemeral value because that's what's the applied one, the system level. Your question goes into the next observation, which is, let me finish the other piece of get.
Okay.
The other piece of get is you're going to get any config false nodes that are present. That's just a normal thing. That doesn't change with I2RS. The fact that something's ephemeral operational state really is just where it lives in the module.
Jeff, because you said you're going to get the config false, and you said you're going to get applied config, I'm confused because it's under the config true, actually.
You get both.
Get will get you both.
Get gets you both configuration and config false state.
Config, get config, you will get config true.
And now we get to get config, and this is where we start getting to these subtleties. And this is really where our discussion is with netconf. How do we actually figure out when we have these things that are overlays of some sort? We now have to figure out what thing do I really mean to get. When I do get, most user applications want to see, for example, what is my applied configuration state. When you have an ephemeral thing, you want to see that thermostat's been set to 18 and not the 20. Same thing for operational state. You want to see what's actually running. But how do you actually see where the thing's coming from? How do I actually ask the system what is the actual static configuration that you're going to return to if I'm actually writing a system to manage the static configuration? I want to do a get config. What does that return? Does it return the static configuration, which is running? Does it return, the ephemeral configuration? The get config RPC does specify a source, operation. You could say source running. That is 100% clear. That's always the static config. You could say source ephemeral. That is 100% clear. The thing that we don't really have is sort of a logical view, a union that says, show me the thing that is on top in terms of the configuration. I want to know what the config is where the static and the ephemeral are interacting. That operation is not a thing that is currently clear and present in the netconf protocol. And this is sort of our request to netconf is how do we go about implementing this?
Jason Stern here. Another thought just occurred to me. That combination may also be not one and the same as the applied.
Bingo.
Yeah.
And this is where the interaction with the OpenConfig stuff, because we were talking about this ephemeral stuff before OpenConfig made our lives even more complicated. So we do have to reconcile that sort of big view, and this is part of what the OpenConfig guys are asking for. What might be the protocol configuration changes, the RPC changes, to allow you to see each of these either logical views or operating views.
John Messenger, I don't want to get into a debate about this, but it just seems to me that you should be having this discussion not in here at all, but only in NetConf.
Yes.
Please.
So the reason why we're actually having this discussion here is because when you ask any three people inside of NetConf for help on this, we get slightly three different answers. This is
So now you've got 4.
now we now have 4. So part of the goal of this session here, because we've had these discussions several times with the guys in NetConf, is to get the majority of the I2RS working group behind what the ideas mean. Let's not fuss over what the terminology is in terms of the functional components. So what are the functional requirements? Understanding the functional requirements, let's refine the functional requirements so they can be implemented against what NetConf is providing in their protocol, inside of their RPC operations, and inside of the interaction not only with ephemeral config and static config, but also the OpenConfig operational state stuff.
Hence our both approach toward operational code, running code, and rough consensus.
So again, it's like the protocol operations in NetConf, not really hard, but the trouble is, we have strong, context of when you do a get's normally going to give you config plus, your operational state, your config false stuff. Maybe we want to have a filter attached to get, and this is one of the things that the ephemeral protocol requirements document that we put together to try to help NetConf understand this. Maybe sometimes we want to get the actual state that was present and configured. I want to retrieve the fact that this was 20 because get can give you the running state as well. Maybe I want to get only the ephemeral pieces of configuration. And one of the requests from the OpenConfig guys for the op state stuff, I want to be able to get the intended versus the derived state. Intended, applied, derived. The sort of lag between these different things, or the fact that you may have an interface configured duplex, or you may have an interface configured auto. You want to see what it actually is.
There are 3 things here that you might want to get, right? You might want to get the light blue box, or the green box, or the dark blue box.
Exactly.
Okay. The next session starts in 7 minutes. I'm sorry to say. This is a great discussion. I love that we're having it, but I think we might be out of time.
I think we are out of time, but more importantly, again, for the room, do you feel like you understand why this is confusing? And more importantly, and now, but do you also have, hopefully, a feeling for what the things involved are, the functional components, and why the existing operations that are available in the protocols are not fully extended for the the cases to retrieve these different versions of the information.
Whoever made that box at the top running, it really should be the blue box.
Well, again, remember, this is NetConf, and this was their data store name. Go blame them.
Thank you for attending, and thank you for all the questions. The more you ask, the better we can write examples in the document. Appreciate it, Bill, and everyone else. Thank you, Jason.
Okay, else, I think I understand it now, but ask me again tomorrow.
So actually, the last item here is if you think you understand it now, let's help us work on the I2RS documents, get them out and published, and then say we're not going to talk about this ever again until NetConf actually gives us something. We have cool models to work on.
Here, I am